all, Mrs. Arndt here. This is your Math 3 Week 6 Lesson 1, and it is all about linear trig equations. So what are we going to be doing today? We are going to be solving linear trig equations to find an unknown value of x or theta. A missing angle is what we're solving for. So you might be thinking to yourself, we've done some of this before. We have found some missing angles in right triangles, and you're absolutely right. But what about in the grander scheme of sine, cosine, and tangent? What about those values? So this first question, where does sine of theta equal 0.21 for theta being between 0 and 360 degrees? So the first thing you might think about doing is making sure you are in the degree mode. We want to be in degree mode. So check your Delta Math calculator under the functions. Make sure it's blacking out over degree, or on your calculator, make sure the same. And you would run inverse sine of 0.21, because for us to input the ratio and get the angle out as an answer, we would have to use inverse sine of that ratio. And to the nearest tenth, we get 12.1 degrees. So in our coordinate plane, or in our unit circle, in our polar situation, 12.1 degrees, that's here in quadrant 1. It's a really small angle, of course, and that's where all of the trig ratios are positive. Okay, but where else is sine positive? Where else could there be an answer to this question? Well, sine is positive in quadrant 2, because sine is based on y, and y is positive in quadrants 1 and 2. So if we reflect that same angle into quadrant 2, using that same reference angle, that's another angle that would have this exact same y height or same y ratio. So for us to find that other angle, we're going to take 180 degrees minus that 12.1. And so the second answer is located at 167.9 degrees. And so if we want to check our work, we would take sine of 167.9. And that gets us that same ratio that's really close to 0.21. So how does this look maybe when we're using cosine, or when we're using tangent, or when perhaps we're looking for something that's actually negative? How does this look? So our job is to solve for all values for the angle between 0 and 360 degrees. So for all of these problems, there will be two solutions. That's what we're looking for. So here in example 1, it says 3 times cosine of x equals -2. So we need to first isolate the trig function. So there's this 3 times it. We need to divide by 3 to get rid of that. Divide by 3 on both sides. So it's asking us to locate an angle where the cosine ratio is equal to -2/3. Okay, so our first answer we're going to get by running inverse cosine on that exact ratio. Inverse cosine of -2/3 is about 131.8 degrees. So that's the first answer that the calculator gave us. Well, if we're thinking about the coordinate plane, 131 degrees is somewhere right about there. That's in quadrant 2. It's in quadrant 2 because cosine is negative in quadrant 2. Cosine is based on x values, or x parts of the coordinate pair. So where else is cosine negative? Well, it's in quadrant 3 also. Quadrant 3. That's where x is also negative. So we're going to need some more information. So this first angle we got of 131.8 degrees. We're reflecting that down. So that means that down here, that's also 131.8 degrees. But we want to make sure that we are rotating and getting an answer that is positive between 0 and 360. So if I take the full circle 360 minus the 131.8, it spits out my second answer of 228.2 degrees. And that makes sense. That's in quadrant 3. If we want to check our work, well, yeah, let's take cosine of 228.2 and see if we get close to the fraction or the decimal for -2/3. So -0.66 repeating. Yeah, that's pretty close. Okay, so it takes a little bit of work. Maybe it takes a little bit of graphing. Let's look at a couple more examples of what you might run into. 2 times the cosine of theta minus 3 equals 5 times the cosine of theta minus 5. So we have a couple things going on here. We have some extra constants, and so we need to collect all of the constants on one side. Let's add 3 to both sides. That leaves me with 2 times the cosine of theta equals 5 times the cosine of theta minus 2. Next up, we would want to collect all of the cosine terms onto the left side. So I'm going to subtract these 5 cosines from both sides. And that tells me negative 3 cosine of theta is equal to negative 2. This is kind of looking a little bit like the last problem. But in our last step here, we divide by negative 3. And so it turns out cosine of theta is equal to positive 2/3 because 2 negatives divided cancel out. So cosine of theta equals 2/3. So our first step to finding our first answer is to run the inverse cosine of 2/3. And that spits out about 48.2 degrees. 48.2. Well, if we draw that picture, 48.2 degrees is here in quadrant 1. It's in quadrant 1 because that's where cosine is positive. Well, where else is cosine going to be that positive 2/3 ratio? Well, if we take a quick look up here, cosine is also positive in quadrant 4 because those x values are positive on the right half of the graph. So we want this angle that's reflected down into quadrant 4. So if this was 48.2 and we reflect it across the x-axis, that's also 48.2. So now to find our second answer between 0 and 360, we'll take 360 minus the 48.2 to get 311.8 degrees. And once again, if you want to check your work, run the cosine of 311.8. Make sure that it's close to the decimal for 2/3. Everything looks good there. If you feel pretty comfortable with that, head on over to Delta Math to practice these problems. If you'd like to see one more, here's an important note. On Delta Math, because there are 2 solutions to all these problems, be sure to put a comma between the 2, and that will allow you to enter 2 solutions. So be sure to use a comma. So here on example 3, this one's with a tangent, and it's kind of similar to the last one where we have some extra constants. So if I subtract 6 from both sides, what happens is the constants are gone. So we have 11 times the tangent of c equals 3 times the tangent of c. We still need to move all the tangents together, so I'm going to subtract 3 tangents from both sides. That tells me 8 tangent of c is equal to nothing. The number for nothing is 0. All right, so finishing this off, isolating tangent by dividing, I'm looking for places where tangent of c equals 0. So inverse tangent of the ratio 0 tells me 0 degrees. 0 degrees. This is on an axis. On an axis. That's where tangent is 0. Where else is tangent going to be equal to 0? Where the y ratio over the x ratio gives us 0. Well, the only way that can happen is when the numerator, or y, is 0. The other place for that would be half a circle away, right on the negative x-axis. So 180 degrees is our other solution. To test it out, tangent of 180 is 0. All right, so keeping in mind that all ratios are positive in quadrant 1, over in quadrant 2, sine is the only positive one, which means cosine and tangent are both negative. In quadrant 3, tangent's the only positive, which means sine and cosine are both negative. And lastly, in quadrant 4, cosine is the only positive one, which means sine and tangent are negative there. So head on over to Delta Math, practice those problems, and good luck out there.